Hi, welcome to the session Topology Reconstruction, Quad Remeshing process. Here you will learn how to reconstruct a topology optimization result into a solid CID geometry using the component convert to quad mesh. You will convert a low-quality triangular mesh into a high-quality quad mesh and then convert that into a smooth solid body. Getting to know this workflow on a basic example will help you when reconstructing more complex geometries. Let's start by taking a look at the inputs. So, of course, when we want to reconstruct a topology optimization result, we need the result, which is internalized here, and it's the optimized topology of the cantilever beam that we are working with in all these examples. If you would like to know how to optimize a topology, please take a look at the topology optimization session and learn more about it. And if we zoom in closely into this imported mesh, we can see that it's a triangular mesh, or that the cells are triangular, and it's quite rocky and bumpy, so it's not smooth. The quality is not very nice. Also, an input is the non-design space. So these are our two inputs, and our goal is to convert this topo result or the isomesh into a solid CID geometry. And if we would try to do it right away with this mesh, probably the component would fail, or we would get a really bad result because the mesh quality is too low. So our first step is to convert the mesh. We want to convert it to a quad mesh that is smoother and has a better quality. Use the convert to quad mesh component, plug in the mesh, and also you have to enter either an edge length or the face count, and we will go with 0.5 for the edge length. Plug this in here, and now the component can calculate and convert the topo result into a quad mesh. This is our result. As you can see, it looks much nicer and smoother. It's only quad cells. If you take a look at the component, you can see that there's a drop-down menu for the settings. And I don't want to touch this again because we will use it for the further calculation, but I want to talk a little bit about the different settings. So down here I already prepared another component, the same component with different settings. So as you can see here, the edge length is a bit shorter, so we get a finer mesh. And you can try yourself to manipulate the mesh by dragging the edge length slider, and as you can see right now, the cells have different sizes. That's because we allow the face size to adapt to the curvature of the geometry. We can change that and dictate the same size for all cells like this. And also, when we allow the adaptation of the face size to the curvature, we can also allow the quad count to adapt to get an ideal size for the curvature. Then also we right now have selected a symmetric result. We can turn this off. Get a slightly different result. As the mesh is nearly symmetric, it doesn't make a huge difference. And then also we currently detect the hard edges, so these are the hard edges that are detected. If we turn this input off, you can see a slight change in the result. Okay, so I will blend out this example again. You can use this to play around with the input settings and have a look at how the quad mesh adapts. So now we have a high quality quad mesh and we are ready to convert it into a solid geometry. So let's take this output and use the mesh to solid component. The mesh to solid component tries to combine cells or the faces of cells together to create surface patches so that we have a low number of different surfaces in the solid geometry. And this is the result. As you can see, we have quite large surface patches, so wherever it works, the component will combine different faces of cells to create large surface patches. Okay, so now everything basically that's left to do is to combine the solid body with the design space, the non-design space again. So plug this into the union component together with the non-design space to unify those two geometries. If I blend this unified body in, you see it's the same, and we have the output bodies and the output new edges from this component. If you just use the basic container for curves and plug in the new edges, you see that these are the newly created edges, these blue lines. And right now in the solid geometry, this is a result that is fine, it works. However, it would be much nicer to fillet these edges. So this is our last step. What we are going to do, we will fillet these new edges. Use the fillet edges component, and we want to fillet the edges on the unified body with a set radii. Blend out the union body, otherwise you won't be able to see the result. And here we have the body with fillet edges. You can change up the radii and the fillet type and then see how the result changes in the viewer. As you can see. So feel free to play around with the different sliders and settings. We achieved our final body, and keep in mind that this workflow has a bit more computation time than most of the workflow. So if you change something in the beginning, you might need to wait like 2 or 3 minutes for the whole workflow to recalculate. So it might make sense to try around with this component if you're thinking about the convert to quad mesh component and how the different settings impact the mesh itself. In this session, you learned how to create a smooth, solid body from a topology optimization result using the convert to quad mesh component.